All right, so small files. The next topic here is I often kind of describe this as the small files problem, but let's kind of talk about what small files are in general. Typically, this use case is driven by streaming use cases. And if you think of let's maybe translate this to a non-streaming, like more of a batch use case. Let's say we're writing into an Iceberg table once a day. So once a day, we go read a bunch of data from some source. Maybe it's a CSV output we got from a SaaS application. And once a day, we write that data into an Iceberg table, right? Once a day, we get a new snapshot of that Iceberg table, which has, I don't know, a handful of data files that make up the batch of data that we loaded in, right? So a batch use case, pretty straightforward. One snapshot a day, a few groups of data files a day. And each batch of data that we write into is relatively optimized. Right. Now, in the streaming world, remember that when writing into Iceberg, each time we write to an Iceberg table creates a new snapshot of data. So think about a scenario where you're streaming into an Iceberg table once per minute. Now, that's not fundamentally wrong, right? There's no problem with that concept. The consideration, though, is that each minute you're going to get a new snapshot of the table because there was data written in each minute. And each minute, each snapshot of the table will include additional metadata files, include additional manifest files, and include additional data files that include data from that minute. Right. So when streaming into Iceberg tables, you get lots of files, right? And I call them small files. They may not actually be that small, but there are going to be lots of them, right? And sorting actually has a play in this. Remember, sorting is a table configuration in Iceberg. So when you write data into an Iceberg table and do it in this streaming fashion, only data within that one file is actually sorted. Right? So if you're writing data into Iceberg in a streaming fashion and you get one set of files per minute, your data is actually only really sorted within the minute that you're writing into. So these streaming use cases get very difficult in an Iceberg perspective, right? You get lots of files, lots of metadata, lots of manifests, and your sorting is not as effective in these scenarios because of that. And querying from these sorts of tables is a common challenge, right? I said querying from these tables can be very expensive, and that's expensive in both definitions of the word. It's expensive in terms of performance, right? Because every time you query a table that's being written into once per minute, let's assume you're doing that over 2 days. If my math is correct, that at minimum, you would have around 2,800 files and probably more because most of your writes might be multiple files. So if you want to query for data over the last 48 hours, you have to open 2,800 files, and actually more because you've got to open a metadata file, a manifest file, and a data file, read the data out of it, and then close it. So there's a lot of overhead just from opening and closing that many files. Not to mention the merge on read overhead of if your data is changing and you need to merge together rows of data to give you a consistent set, you're not only opening and closing 2,800 files, you're merging together rows across 2,800 files, which could be very expensive. And again, expensive both from the how long does the query take perspective, but also on a cost standpoint, right? Most of these Iceberg tables are going to run in the cloud. There's a cost to API accesses across files. And so it'll actually hit your AWS bill or your cloud compute bill if you have to read from lots of small files. Right. So Iceberg in these use cases, and actually in a lot of use cases, recommends a lot of maintenance to make tables much more efficient, right? And drive down cost, both from a performance as well as a monetary cost perspective. And there's a few that Iceberg always recommends. If you actually go to the Iceberg documentation, they break maintenance into a always recommended and then occasionally recommended section. And the always recommended section one is expiring unneeded snapshots, right? Remember, every time you write data into an Iceberg table, it creates a snapshot. A snapshot points to a metadata, a snapshot points to a manifest list, which points to manifest files, which points to data files. So based on your business requirements, you are unlikely to need an infinite number of snapshots. I think the default in Iceberg is, don't quote me on this, it's like 5 days or something like that. But think through the business use case of how long do we need snapshots around for? You know, for how long are we going to need to time travel to understand previous copies of the data? And then set your snapshot expiration based on that time, right? For many use cases, it might be minutes, right? If it's a streaming use case, you know, maybe we only need to keep the last 24 hours of snapshots or the last few hours of snapshots. Nice thing about expiring snapshots is when you expire a snapshot, it's no longer, now one, it's no longer available for time travel, but then also Iceberg is able to remove and clean up files that are no longer needed. Right, so you can expire a snapshot, and then for expired snapshots, there's also ways to clean up and delete metadata files and manifest lists and data files themselves to keep your Iceberg table in a much healthier state. This will have a slight impact on performance by removing unneeded snapshots because the metadata files won't be as large. But this will mostly have a positive impact on just space storage consumption, right? I think back in our polling, it showed that over 50% of the audience's primary concern was reducing storage usage in Iceberg, and expiring snapshots that aren't needed is definitely the first thing that I look at for that. The other thing that Iceberg recommends is to delete orphan files. Orphan files are basically data files that are no longer being referenced by a manifest file. Now, other types of Iceberg maintenance should be cleaning these files up, but if a job fails or a task fails or maintenance isn't working as it should, there's a lot of scenarios where you end up with these orphaned files. And depending on the processing engine that you're using or the technology that you're using, there are various ways that you can identify and then delete orphaned files. The Iceberg doc specifically mentioned a Spark command that can be used to find and delete orphaned files. And it's not something you need to do often. It actually can be a relatively expensive process to clean them up, but every once in a while, it's a good idea to try to identify them and then clean up any files that are no longer referenced by a metadata file. So whether you're loading data into Iceberg in batch or in streaming, that type of maintenance will help. But moving back to the small file problem, and specifically around streaming use cases, remember that frequent Iceberg writes create lots of manifest files and lots of small data files. When you query from that data, from that table, every time you process a query, it's going to have to open, read, and then close a large number of small files. And you can get significant performance gains by running compactions, right? Now, compactions is not a unique concept to Iceberg. This small file problem existed in Hive and continues in Iceberg. In some ways, it's actually made worse, but it continues. And so compaction is, especially in streaming use cases, is very much a recommended maintenance. Iceberg itself includes compaction procedures. Various other processing engines include compaction. A lot of the vendor ecosystem that's out there might have their own proprietary method of compaction, but fundamentally, compaction is the conversion of lots of small files into fewer larger files. Right? If you're compacting, let's say, a day's worth of data, you've got 1,440 minutes worth of files that can be compacted potentially into a single data file for that one day. The other nice thing about compaction is that data can be resorted into these larger data files. So when compacting lots of small files into fewer larger files, you'll get better benefit from the sorting that's been defined by your Iceberg configuration, because those files are going to be much better sorted since they're larger and they contain more data. Now, again, Iceberg contains a rewrite data files procedure. It takes a few different parameters: how far back to go, what's your target data file size. This is a bit of a balancing act. but there's some considerations that you can leverage to determine what's a best use case. In general, what you want to think about when defining a compaction strategy is every time you compact data, there's going to be a compute requirement, right? It takes compute resources to run these compactions. Now, obviously, the benefits are going to be much improved query performance. So you need to kind of think about what is your appetite for additional compute cost compared to how important is it that the queries that run on these tables run as efficiently as possible, right? And I can't necessarily make a recommendation there other than it's something you need to consider. If the tables are rarely queried, and when the queries run, performance, in other words, how long the queries run for, is not a huge concern, then honestly, I wouldn't run compaction very often, right? That said, if these are tables that are used frequently and performance is critical, then run compaction a lot, right? You'll get a lot of benefits out of it.